Intro Algebra Lesson 1-7A. Today we're going to talk about something that can be a little bit complex. I'm going to try to make it as simple as I can, and that is what's called a function. Now that's a really fancy sounding word, but basically what it means is it's a rule. And that rule could be really easy or that rule could be really complicated. It changes. It all depends on the function that you're working with. All right? But it's a rule that establishes a relationship. Now, a relationship is just another way of saying a connection between the numbers, between two quantities, which we will refer to as our inputs and our outputs. All right? Now, I've written down here a few different possible rules. These are all rules. Like you might say, okay, I want to use the function that says add 5. That means that no matter number I plug in, I'm going to add 5 to it. If I said, okay, what about if I apply the function's rule to 3? Well, 3 plus 5 is 8. So the number that went in was 3, and out came the number 8. If I wanted to know what it would be if this were 100, all right? So then if I plugged 100 in, that's my input, I'd apply the rule to it, and I would get an answer of 105. So I'm going to apply the rule to no matter what comes in. So I want you to think of function as a supercomputer. So this is the supercomputer. The supercomputer can change the rule all the time. So let's say I go back to this rule and I say, okay, the supercomputer says I'm going to use the number, I'm going to add 5 to whatever I have here. So here's in, and here's out. Remember, I was talking about the function. I said two quantities, input and output. So I'm going to plug a number into this supercomputer. I'm going to put the number 7 in. So I take 7, and I stick number 7 into the computer, and out pops 12. 7 plus 5 is 12. When the number 7 went in, out came 12. All right? But maybe I have a different number. Maybe I don't put 7 in. Maybe I plug in 10. Okay, if I plug 10 in, put 10 in there, I get 15 out. I've applied the rule to my number. And I could do this as long as I want to. What happens if maybe I set this 10 off to the side for a moment and I do a whole bunch of other numbers? And then I come back and I plug 10 in. Is it going to give me a different answer this time? No. I'm going to get 15. I'm still going to get the same value. When I plug a value in, I get the same number out if I'm doing the same, same rule, the same function. Okay, this time let's put it in times by 2. Now this is a different rule. Well, if I put 10 in, 10 times by 2 would give me 20. The number goes in, I get a different value out. Maybe the rule is times by 3, and then subtract 2. A little bit more complicated. As 10 goes in, plug a number in, 10 times 3 is 30, 30 minus 2 is 28. So I get an output. Numbers go in, math takes place, out pops an answer. So the rules can change. It all depends on what rule you have, but you're going to stick numbers in, something will happen. A rule will be applied, and then you'll get a number out. So, when we make those, we call them input-output tables. Because we choose a whole bunch of values, or maybe we're given values to stick in, we apply the rule to the problem, and we get a result, an answer out. That's the list of all the input and output tables. Okay? So, here we have a few input-output tables blank that they would look like. Each input, in order for something to be an input, that's all these right here, each input is going to have exactly one output. Here's what I mean by that. Say I had 0, 1, 2, 1, 3. Now I just made up these numbers. And let's say there was some sort of a function that this was applied to, and the outcomes were 7, 8, 9, and 8, and 10. Alright? And you were asked, is this really a function? Well, let's look. According to the rule, in order for it to be a function, there has to be exactly one output for every one of the inputs. Well, here, 0 became 7 after the rule was applied. 1 became 8. 2 became 9. But look, here's 1 again. It's the same input. Luckily, it produced the same output. And then when 3 went in, it produced a 10. So in order for something to actually be a function, if you have a number here and it produces an 8, later on that same number better produce the same 8. Otherwise, it's not a function. So this one. 0, 1, 2, 1, 3. Now let's say we got 4, 5, 6, 7, 8. Is this a function? The answer would be no. And the reason? Because here, if 1 went in, it produced a 5, but later 1 went in and it produced a 7. That's a no-no. Can't have that. So this is not a function, and this is a function. It's all based on the inputs. This is not a function. So I'll plug another one in here. We'll make one more. This time I'll make another function. Maybe it's 0, 2, 4, 2, 8. Now, are there any repeating inputs? Yep, right here. If it's going to be a function, can these outputs be different? No, they have to be the same. So 3, 6, we could say 9. This better be 6 again, and then possibly 12. Okay? So this is my outputs. As long as the same input produces the same output, we're okay. Alright, now the definition for output is a little different, because I know that I said that for every input it must get the same result, but for outputs it's possible that different inputs could all have the same answer. I know that's complicated, and I'll try to give you some examples of that. So more than one input can have the same output. Let's look at some examples of that. What that means is if you have 0, 1, 2, 3, 4, it's possible that you could have 5, 5, 5, 5, 5. And you might say, what? Well, there's nothing that says all these inputs can't have the same output. That's perfectly legal. What would be a problem is if there was a 1 and then later on a 1 that had a different answer. Like this. Let's say it was 0, 1, 2, 1, 3. And you had 5, 5, 5, 6, 5. This would not be a function. And it's not because there's a whole bunch of 5s. It's because this one had a 5, but this one had a 6. So it doesn't matter if a whole bunch of numbers produce the same output. That's okay. You just can't have an input produce one output, later on that same input produce a different output. This is not a function. Not a function. But the other one, the first one, is a function. So let's see what we can do on this last one. We'll try to make another one that is. Alright, if it is a function, we could say 0, 1, 2, 3, 2. And maybe as far as outputs, I could go 4, 3. I better have the same 2. Down here, this 2 better also be a 2, and 3 could be 1. So this is still a function. Alright? If I wanted to make them all the same values, I could say 10, 10, 10, 10, 10. That's okay also, because once again, that 2 and that 2 produce the same output. That's alright. Don't get caught up on the answers unless it's the same input. It better produce the same output. Other than that, it's okay if they have ties. Okay? Alright, so domain. Domain is what we refer to as all the input values. So if we had this right here, and we had 1, 2, 3, 4, 5, and you had over here 10, 20, 30, 40, 50, the domain would simply be 1, 2, 3, 4, 5, all the inputs. And you could say D for domain, 1, 2, 3, 4, 5. Alright? If this changes, if it's now 1, 1, 2, 3, 4, you don't have to write 1 more than once. Once you've written down a number, it's already part of the domain. Even if it repeats itself, it's already there. You don't have to write it a second time. We also have what we call the range. Now the range is all the output values. So if we have 0, 1, 2, 3, 4, maybe our outputs are 6, 7, 8, 9, 10. So we would say R for range, and we would go 6, 7, 8, 9, 10. But what if that changed? What if we didn't have those outputs? What if we had this for outputs? If we had 6, 6, 7, 7, 8. Is that okay? Sure, it's okay. It's still a function. But when it comes to writing down the range, we don't need to list each number multiple times. We just say 6, 7, 8. That would be the range this time. Yeah, but there's more. I know there is, but 6 is already represented. Alright? Now, a little bit complicated, a little bit more. It says make an input-output table for the function. I haven't given you the function yet, but it tells us use 0, 2, 4, 6, 8 as the domain. And what does domain mean? Domain is all the inputs, the numbers going in. So here's the function, y equals 3x minus 3. What we need to do is put the domain here. 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. And one at a time, plug the number in. Take this and plug it in here for x. So what's 3 times 0? 0. What's 0 minus 3? Negative 3. Okay, so we plug that in. Next, you start over. Now you put 2 in. So now 2 goes here. Okay, well, 3 times 2 is 6. 6 minus 3 is 3. We take that out. We now have this, 3. Then you plug 4 in. 3 times 4 is 12. 12 minus 3 is 9. Then you plug 6 in. 3 times 6 is 18. 18 minus 3, 15. Alright? So there's definitely a pattern taking place. Plug 8 in. 3 times 8, 24. 24 minus 3, 21. That's how you would make your input-output table. Don't try to stick all these numbers in at once. Plug them in one at a time. And lastly, the ways to describe a function are on page 47. There are a number of ways. We focused on input-output tables today. But it's possible that you could describe them in words. If I were to describe this function in words, I would say, take your input, multiply by 3, and then subtract 3. That's how I described it in words. That's what I want you to do with the rule. But you could also have an equation, which we have right here. This is an equation that represents a function. Remember, a function is a rule. And lastly, you have graphs. We have not talked about graphs yet, but we will.